So let's get started with our EC2, in which we are going to go and create the instances finally. But then again, one important thing. Inside EC2, it's pretty easy to go and create a server. By this, go and give a name. Select the operating system, let's say Ubuntu 22, and go and select the machine type that we understand, T2, T3, T4, M4, M5, M6. So if you have selected a x86, needless to say, you should ideally not go and select T4G instance. Even if you want to, this is disabled if you see. Okay, if you go and select T3, this can very well be selected. Similarly, if you go and select M5, this can be selected. However, if you go for M6, over here, M6I can be selected, but M6G over here is automatically disabled. This also I want to believe you understand, because these are the ARM instances. And in the top itself, you have told that I am looking for a x86 machine. Also, I would want to believe that you understand that if I go for Microsoft, I do not see any option of the architecture coming up. I do not see x86 or ARM, rather I only see x86. Similarly, inside Ubuntu, I will see both x86 ARM. Linux, I will see both. RHEL, I will see both. SUSE, I will see both. And if you go here, Mac OS, over here, I cannot see, because Mac OS gives me only one type of instance, Mac OS itself. Similarly, Debian over here will give me both x86 and ARM. However, Microsoft only gives me x86. This thing we had already discussed earlier when we said that Microsoft OS is still testing out ARM instances as we speak. It's only testing them out. It's not live, at least as of now. And if I go for Ubuntu, I have option to select any of the machines. Now, which one will I select, x86 or ARM? That depends on your personal preference and what the client actually is looking for. But anyways, if you are going for x86 instance or for a ARM instance, remember ARM are way cheaper, because Graviton internal AWS processors optimized for AWS. AWS says it is fast. Me personally, I don't see much of a difference. Honestly, it feels the same to me. But then again, if I had an option to choose x86 versus ARM, because ARM did give me the performance almost equal to x86, so I will choose ARM, because the primary reason is ARM is exactly half of your x86. So if in x86 I have to pay $300, in ARM I only have to pay $150. Which brings me to the question, what is the proof of that? When you say ARM instances are way cheaper, the answer very quickly, RI over here, let's go for an instance, let's say uh, T2X large. Okay, so let's say T2X large. 3 years, or let's say take it only for 1 year. I will pay everything right now. I am looking for a standard. And so T2X large will charge me $1,011. $1,000 for T2X large. Similarly, if I go for T4X large, which is the same thing, so remember the number $1,000. So T4G X large, if I search, I only have to pay $463. T2 is 1011. T4G ARM is $463. So which one will I go for? You know the answer. Now, even if you say no, that performance has a slight dip in T4G, no issues. In the same price, I can go and buy two servers of T4GX large, which would be actually $926, two instances, and still I would be saving $85 on top of T2. So I will be saving more also, and I will be having two instances. For that reason, actually, I would always prefer going for a T4GX large. Anyways, how I go and choose an instance entirely depends on the clients. because not all softwares, like we know, are created for ARM machines. Rather, everything is always created for x86. ARM is also catching up now, but it's not there as we speak. Anyways, going back to the server, assuming I go and create something as a web server for Ubuntu 22. By the way, very quickly, I see Ubuntu 22 LTS, LTS, LTS. What is this LTS? Do we understand? Good. First, let's go and understand what LTS is. But this I would have also answered inside your DevOps. But for now, let's see what LTS actually stands for. So what happens, like packages, I am taking Ubuntu because this is one of the most highly popular operating system that is used in the market. First thing. Second, Ubuntu operating system comes, or just like Windows comes in after many years. Ubuntu actually will release a new version every year, just like your Mac OS. Every year there would be a new version of Ubuntu. For example, these are the versions: 14, 16, 18, 20, 22. Very quickly, 14 simply means it came in 2014. 16 means it came in 2016, similarly 18, similarly 20, similarly 2022. After that, this O4, no, actually means it was launched in April. Ubuntu anyhow launches in April only. So that is not a big thing. So this 1404, no, actually means it was launched in 2014 and in the month of April. This is first part. So you would be having 14, 16, 18, 20, 22. Just by looking at this, you can understand the next version would be 2404, which would be launched in April 2024, which means each of these releases have a duration gap of 2 years. Or rather, let me rephrase. You see this LTS. LTS stands for long term support. In simple term, it means if I am creating a software in 2014, I would give you support up till 5 years, 2019, and I would be giving you external support till 2024. External support means basically security updates I would be giving, and if in case you are a premium customer, I would be giving you support for 10 years. So Ubuntu 14 is still having support up till 2024. Now it becomes very easy. 2016 it came, so support would be till 5 years, 2021, and long term support or security updates would be for 10 years, which is 2026. Similarly, the one which came out in 2022 in April, very recently, it has support for 5 years, which is 2027, and the security updates will be there till 10 years, which will be 2032. That is how the version history of Ubuntu is, but that is not it actually. This we are only talking about LTS. LTS is not the only release. If you pay attention now, just have a look. It's pretty complex, and if you go down, but let me tell you by something like this. These are the releases actually. Now, 1404 was a LTS. So it was launched in 2014 in the month of April. Something was launched in 2014 October also. That is not LTS. LTS only comes once in 2 years. So it was created in 2014 in October also. Then in 2015 also something came in April. That is again not LTS. And then something again came in 2015 in October, which was again not LTS. In short, every even year in April, you will have a LTS. In the same year in October, you will have a update which will not be LTS, which is 1610, 1810, 2010, 2210 would be there. Similarly, in the next year or the odd year in April, you will again have a release which will again not be LTS. And then similarly in the odd year again in 2000 in October you will have a release which will again not be a long-term support. But anyways, if you see this LTS, the only difference is LTS will give you support for 5 years and security updates for 10 years. Whereas non-LTS will only give you exactly for few months. See over here, 1410 came in 2014, update stopped in 2015 itself. 1510 or 1504 came in 2015, stopped in 2016, or support stopped. Similarly, 1510 came in October 2015, stopped in June 2028. Sorry, July 2016 itself. So anything that is not LTS, right, will have very short support. So anything which is non-LTS generally means doesn't have the update. And if it doesn't have the update, then what is the point of keeping such an operating system? For that reason, if you go to EC2, you will see I always start to see LTS, LTS, LTS. That is the whole story behind selecting the specific operating system. AWS will never keep anything which is non-LTS. Why? Support itself is not there, so there's no point of keeping or saving a instance which is a non-LTS instance. That's the story behind your Ubuntu version history. Now, earlier you only had this started back from Ubuntu started back in 2004, but this LTS thing they have been following since 2006. Okay, to 606, 10, 7, 4, 8, 10, 12, 14, 16, 18, and 20. This, by the way, is what your timeline stands for. Anything which is long will always be a LTS. Orange means normal support, red means extended support. This blue line is where we are at the moment. Looking at this blue line, you can understand Ubuntu 14 is still having security update. 16 is having security update. 18 is having normal updates also, which will stop in 5 years, 2023, somewhere over here. 20 is having updates until 2025. 22 support has only started. This, you see, is the whole story behind LTS. If you understood this, good for you. If you didn't understand, that is also fine. This you actually need it once you go and start working a lot on operating systems. And by the way, each of these operating systems will have a code name of their own. For example, this is the code name. Trusty, Xenial, Bionic, Focal, Ubuntu 22 is known as Jammy. Okay, so if you ever go and search for Ubuntu 22, like we'll go and search also, create the instances, the version will always give you something like this: Jammy, Focal, Bionic, something like this. So in case you see, this Jammy and Focal and Bionic, don't be confused. This actually is your name of your operating system. Like you saw, this Focal is nothing but Ubuntu 20. So don't be confused. Some people will call it by the code name Focal. Some people will say Ubuntu 20. It depends on how you are looking at the instances actually. Okay, so whenever you have a update or something, it will come in by this version number also or by this also. For example, if I have to go for MongoDB and let's say I'm looking to download something, MongoDB download over here. So it will ask you that instead of Mac OS, let's say I am going for Ubuntu 18, 18, 20 or 20, whichever you are looking for. So ARM is the ARM machine, 20, this is for ARM. This, if it doesn't say anything, it simply means it's a x86 machine. So just keep that in mind. Also, alternatively, you could have gone for MongoDB and let's say, anyways, you can go MongoDB Ubuntu over here. Now, if you see these versions, it will start to say Ubuntu 20 in double quotes. It says Focal, Bionic, or Xenia, any one of them. Just remember that these are nothing but the code names of your Ubuntu operating system. Some people will call it 22, some people will call it jammy. Okay, anyways, let's go back. Why we came here was because we were trying to create an instance and it told me that you can go for Ubuntu 22 machine, and Ubuntu 22 said that I am LTS, and I was interested in knowing what is LTS, which stands for long-term support. And I know long-term support will come in two ways. It will come in either 5 years or security updates for 10 years. I will go and choose any one of them. And then based on that, I will go and select the operating system, which is also known as AMI or Amazon Machine Image. This basically simply means the operating system along with the softwares which comes in bundled with that specific operating system. Next up is my storage. This part I am ignoring for some time, keep here and network setting. This we will be talking about tomorrow. But right now I am interested about this configure storage, where I see something as GP2, GP3, IO1, IO2, SC1, ST1, and magnetic. Today's class is all about this only. What are the types of storage? By the way, if you forgot, this thing we had already seen inside RDS, relational databases, where when we were talking about relational databases and we wanted to go and create a specific database of any database type you wanted, over here, it had asked you what is the storage type you need. GP2, IO1, magnetic. At that point of time, I had told you, ignore this. Once I am inside EC2 EBS, I will tell you what it means. This is what we are going to do now. Here you see I had only two options, GP2, IO1, magnetic. Here you see GP2, IO1 and magnetic are only 3 out of total 7 options that I have, which actually comes inside something known as EBS. So before I go to EC2, and I create an instance, first I will have to understand storage. Next, I will have to understand network. Then I will have to understand key pair. And if all these things are understood, I will just go select my operating system over here and my instance would automatically be created. You see, EC2 instance inside itself is nothing. EC2 instance is combination of multiple things which includes storage. Storage is nothing but your elastic block store or your volumes. Volume basically is the hard disk or the storage that is present inside your laptop at this moment. So that basically, to create a storage inside AWS, you just have to go and click on create volume and you have all these options present over here. What do these options means? Let's understand that first. So first thing first, whenever you have to go for any storage or any, let's say any type of storage, basically, you will have to select a type of that. Assuming I go for a GP2 type of an instance. So on what type of volume I will go and select, that actually depends on what my use case is. Use case or what my requirement is. What do I mean by that? Let's say I have a volume which wants to do less transactions or more transactions. It depends on that. So this IOPS, you see, no, IOPS. Now, again, I would recommend you to go and just read about IOPS today. Input output per second. This is basically a way to understand how your storage actually works. More IOPS means you are able to do more input output per second or more transactions per second. So more IOPS is always better for me. Okay. So more IOPS is always better. That is one thing. And if I have better IOPS means my storage or my hard disk is actually better. So I have option of GP2, which supports up to 300 IOPS. IOPS is 300. If in case I need more amount of IOPS, I can increase, or rather AWS will automatically increase it to limit of 3000. Now, how does this number actually come and this number actually come? Let's talk about that. You see, it says baseline of 3 IOPS per GB. It simply means if this is 100, no, this will be multiplied by 3. For each 1 GB, I have 3 IOPS. So if it is 100 GB, my IOPS actually will become 300. By that mathematics, if I make it 200 GB, or rather 200 GB, my IOPS becomes 600. Multiplied by 3, simple. By that logic, if I make it 300 GB, my IOPS becomes 900. So this IOPS, if I want to increase, the easiest way is to go and increase the size of my volume. Increasing that also increases my IOPS over here. One thing. Next thing, assuming I have 900 IOPS. So how many transactions at max I can do per second? 900. Now the question is, I want to do more transactions. Instead of 900, I should be able to do 1000 maybe. And not always. If I need 1000 anyhow, no, I will go and make it 400. Then I have 1200 IOPS. But I am saying, see, I will need only 1000 IOPS. Initially start with 900. Maybe for a short burst of 1 second or 2 second or 5 second or 1 minute or 2 minutes or 5 minutes, I might need 1000 IOPS. AWS says, don't worry. Ideally, I will give you 900 IOPS only. But just in case if you need more IOPS, I can scale you up to 3000 IOPS also. But the maximum limit would be 3000 only. Obviously, it means I will charge you more. But nonetheless, you don't have to worry. If in case you need more IOPS, I will give it to you because my burstable IOPS is set to 3000. So by that logic, if I go for 500 GB over here, my IOPS becomes 500 multiplied by 3, which is 1500. And AWS says that just in case if you need more, I can give you more, maximum up to 3000 IOPS. Okay, by that same logic, if I go for 900, I will be having 2700 IOPS. By that same logic, if I want to increase, AWS says it is fine. I can go and increase you up to 3000. You don't have to go and add anything extra to it. I will automatically manage it from my end. So 900 into 3 becomes 2700. And if in case more are required, I can go up to 3000. However, what if I go for 2000 GB? 2000 GB means my IOPS should be 6000. Maximum is 3000 over here. So now pay attention, this will change. In this case, if it is 2000 GB, my IOPS will be 2000 into 3, which would be 6000. Just give me a minute. Okay, so let's assume. So basically, assuming I go for 2000 IOPS. So if I, or rather I go for 2000 GB, in that case, obviously my IOPS is 2000 multiplied by 3, which is 6000. If it is 6000 IOPS, in that case, AWS is giving me maximum to 3000 only. Obviously, I have surpassed the range. So in that case, AWS cannot give me any more IOPS. It will say you have gone for 2000 GB of volume. At max, I can give you 6000 IOPS, and that's pretty much it. Now, assuming I go for more, let's say 5000. So in that case, my IOPS becomes 15,000. Now pay attention. If I go for 6000, ideally 6000 should mean 6000 multiplied by 3, which is 18,000. But AWS is only giving me 16,000 because 16,000 is the maximum that AWS can give me. So in case you need more, I cannot do anything on top of it. I can at max give you 16,000 IOPS only. This thing is important because the maximum capacity of my GP2 volume type is 16,000 only. This thing is important, especially if you are giving the architect level certification in AWS. Remember these numbers. Anyways, going back, assuming I go for 60 GB of volume, 60 into 3 is 180. Maximum I will give you till 3000. By that logic, if I go for 1 GB of volume, I should be having only 3 IOPS, right? No. Minimum I will give you 100 IOPS. So both the limits are there. This thing you will see straight away 100. 16,000 you will not see. So if I am 100 GB, I will give you 300 IOPS up to maximum of 3000. If I am 900 GB, I will give you 2700 IOPS maximum up to 3000. If I am 5000 GB, I will give you IOPS of 15,000. If I am 6000 GB, I should ideally give you 18,000, but I will still give you 16,000 because my maximum capacity is 16,000. And similarly, if I am just 10 GB or 1 GB, I should be giving you 30 IOPS, right? 10 GB into 3, 30. But no, I will not be giving you 30. Minimum, I will give you 100 IOPS. And there is a logic behind it also. 1 GB means 3 IOPS. 3 IOPS is very small number to process actually. 3 IOPS will not do anything for you. So AWS will give you minimum of 100 IOPS anyways. Whether you want multiply by 3 or multiply by 10, I will give you multiplied by 3 or 100 IOPS minimum, maximum up to 16,000, burstable up to 3,000 if you are below that range. This is the whole mathematics behind GP2. But remember, GP2 can only give you IOPS. It cannot give you throughput. Throughput basically simply means that instead of saying, no, I will give you 100 transactions, 200 transactions, 1000 transactions. My throughput means I will give you data at a bandwidth, let's say 10 Mbps, let's say 20 Mbps, 100 Mbps. Where is that required actually? If you have seen Netflix, YouTube, there actually I have to give you data at a specific streaming capacity. 10 Mbps, 20 Mbps, 40 Mbps, their transaction, and especially I'm talking about streaming only. Their transactions don't matter. There what matters is throughput. So just in case if I am into streaming services, in that case transaction won't bother me. What will bother me would be throughput. How much bandwidth are you giving? 10 Mbps, 100 Mbps, 200 Mbps and so on. Okay, that is about your throughput. Next up, GP2. Now the problem with GP2 is IOPS is all mathematics. 10 GB will give me 100, 100 will give me 300, maximum of 3000. 1000 GB will give me 3000 IOPS, 5000 GB will give me 15,000 IOPS, 10,000 GB should give me 30,000 IOPS, but it will give me only 16,000 IOPS. The thing is, if I am creating a volume, I don't want to apply my brain. I will simply say, this is the size, this much IOPS I need. Give me that much IOPS. So how will you get that? The answer is via IO1. This is also known as provisioned IOPS. The only thing is, remember ratio is 1:50. What do I mean? If you are going for 40 GB of storage, at max you can go for 2000 IOPS. Okay, now again you say I have to apply mathematics. No, mathematics is only for the maximum limit. It cannot be that you only take 40 GB of volume and you say I need 2 million IOPS. That anyhow the volume will not support. So if you go for 40 GB or let's go for 40 GB is fine. Let's go for 40 GB. In that case, I am looking for IOPS of 2000. The moment you make it 2001 over here, it will start erroring out because it will say ratio is 1:50. In short, if you are 40 GB at max, you can hit 2000 IOPS. Again, this is provisioned. Provisioned means I am telling you how many operations I need, how many input output per second I mean. That is your IO1. Next up, the concept is just for having 2000 IOPS. Do I need to go with IO1 1 is to 50? Why not something else? Fine, go for IO2. The thing is, for 4 GB itself, you can have 2000 IOPS. Here, the ratio is 1 is to 500. Okay, even if you want to go more, AWS will always allow you. But remember, the ratio generally is supported with IO2, and the ratio is 1 is to 500. So for each 1 GB of storage, you can have 500 IOPS. Very expensive volumes type, very means these are expensive and they are not used also for that reason. Actually, if you go down over here, no, you will only find GP2. Now GP2, remember, IOPS you don't have. Why? Mathematics now you do yourself only. How much you have? 20 GB. 20 GB should have how many IOPS for GP2? 20 multiplied by 3, which is 60. But minimum I will give you 100. So in this case, your IOPS would be 100. So how many transactions can you do with this database? The answer is 100. Say make it 200 GB over here. Now 200 GB means how many IOPS? 200 multiplied by 3, which is 600. So how many transactions can you do inside your RDS at max? Answer is 200 into 3, which is 600. By that logic, make it, let's say, 1000. So in that case, if you go for 1000 GB, how many transactions you can do? At max 1000 into 3, which is 3000. So how many transactions you can do at max? 3000. By that same logic, let's say I go for 800. 800, how much I can do? 800 multiplied by 3 is 2400. But remember, GP2 can also do a burstable thing up to 3000. So in this case also, maximum I can do is 3000 only. Maximum I can do. But ideally, it should be 800 multiplied by 3, which is 2400. Now you say that, no, I want my specific operations. Fine, go for whatever size you want. So 100 GB, if you go over here, you can go for ratio is 1 is to 50, right? So if it is 100, you can go for 5000 IOPS. The moment you make it 5001, it will again error out, because remember, the ratio is 1 is to 50 inside IO1. This thing you did not understand inside RDS. You should understand it now once we are done with IO1 and IO2. By the way, IO2 is still not available inside RDS. So at max, the ratio that you can hit is 1 is to 50. GP2 anyhow is 1 is to 3. And then I have magnetic, where you will realize you don't have anything including IOPS. But more about it after I go down. So GP2 I understand, IOPS, IO1, IO2 I understand. That is nothing but mathematics, 1 is to 50 and 1 is to 500. But there are certain cases in which I will need streaming data. Netflix, YouTube, video processing, all these things, I will need a consistent stream of data to be flowing through my servers. In that case, GP2, IO1, IO2 are not a good approach. Rather, cold HDD or hard disk. Now, very quickly, HDD versus SSD. If you go and today you will just go and Google it and read about it. HDD were used inside the older laptops. So if you don't have a very premier laptop right now, for sure that is using a HDD. Bit slow, but still it is doable, manageable, slow, but it is cheap. Also, is shock resistant up to 55G. SSDs, on the other hand, like you see, is small in size, is compact in size, has shock resistance up to 1500G. Okay, so it is pretty much more durable also, and it is way faster also. The reason is in front of you. It is having a concept of cache and a flash memory. So that's a primary reason why it is so fast. But nonetheless, SSDs are slow, fast, expensive. as compared to HDD, which are bulky, which are big, which are slow, and which are cheaper also for obvious reasons. So this is what SSDs versus HDD will look like in real life. These are your NAND chips actually, which will store the data. Anyways, going back, this HDD is what we see over here. This HDD over here, these big bulky machines, HDD. The good thing is they will support your bandwidth. So for each 1 GB or 1 terabyte, like if I go for 1024 GB, I will be giving you 12 Mbps. So 1024 will give me 12 Mbps, but nonetheless, if I need more, I can go up to 80 Mbps. By that logic, if I go for 2048 or 2 GB, it will become 24 Mbps. By that same logic, if I go for 4 terabyte or 4096, it will become 12 multiplied by 4, which is 48 Mbps. And I can scale you up to 250 Mbps. That is cold HDD, which is bit slow. The number is 12 Mbps for each terabyte of data. By that same logic, this optimized one is somewhat better. This one ratio was 1 is to 12. This one ratio is 1 is to 40. So if you go for 1024 GB, this has 40 Mbps. Similarly, if you go for 2048 GB, this will be 40 multiplied by 2 terabytes, which would be 80 Mbps. And I would give you the bandwidth up till maximum of 500 Mbps. In this one, you do not have IOPS, obviously, but you do have a throughput. So both in a cold HDD and a throughput optimized HDD, you will not have IOPS, rather you will have throughput. On the contrary, GP2, IO1 and IO2 will only have IOPS and it will not have throughput. So depending on your use case, whether you are looking to stream data or you're looking for transactions, you will either choose a SSD or a HDD. Next up, magnetic. Magnetic disk is present here also. It is telling you not recommended because maximum I can give you 1000 IOPS only. So HDD versus this versus if you go for magnetic, basically. So magnetic ones are even cheaper actually. So if you choose magnetic, you will see I neither have IOPS nor I have throughput. So there is absolutely no reason why you will ever choose a magnetic disk because it is expensive, it is slow, it will not support transactions, it will neither support throughput. Nothing good happens with magnetic storage. So ideally, you will never choose it only. But still, it is being offered because some customers who would be working on that would still be using this type of a storage. Finally, RDS basically also gives you the option for magnetic because by the time RDS started, it was already having magnetic and it supports maximum up to 1000 IOPS, though it is very kind enough to tell you, please do not use it. Go for GP2, it is cheap also, it is better also. But nonetheless, if you want to use it, there is nothing stopping you. Okay, fine. So magnetic is this one, and this was what it was until 2020 December. Go for SSDs, GP2, IO1. If you are paying attention, I am ignoring GP3 each time. And there's a reason. So the reason is GP2, one last time pay attention, only IOPS, no throughput. IO1, only IOPS, no throughput. IO2, only IOPS, no throughput. Similarly, cold HTT or SC1, only throughput and no IOPS. Optimized or ST1, only throughput and no IOPS. And magnetic anyhow neither has IOPS nor has throughput. So until December 2020, you only had an option where you could choose in either IOPS or throughput, any one of them. And then AWS introduced the new volume type, which is GP3. GP3 is a general purpose volume again, but the beauty is I have both IOPS as well as throughput. Now this throughput you see no is 125 Mbps for each terabyte. Pay attention. If you had gone for this one over here, ST1 throughput, it was 40 Mbps for each terabyte. On the contrary, 40 Mbps. This one was only 12 Mbps. GP3 actually is 125 Mbps for each terabyte. It is so fast. Here, the ratio is actually, have a look at it yourself. If I go for 4, I can have up to 2000. Or let's make it, let's say, 5. And let's make it 3000. Basically, the ratio is 1 is to 60. It is so blazingly fast. Better than IO2 in case of provision, better than throughput in case of throughput optimized hard disk for the throughput. It is better than both of them actually. Better than my SSDs also, better than my HDD also. And if you have a look at the pricing, it is cheaper than any of the volume types which are available. So first thing that I should ideally be doing is changing my volumes to GP3, not because only the IOPS is better, but throughput also is better. And finally, GP3 is way cheaper than my other volume types. So in short, if now anyone will ask you about the volumes, GP2, GP3, IO1, IO2, the difference is GP3 is the fastest. Ratio is 1 is to 125 Mbps for provisioning. Ratio is 1 is to 500 for IOPS, and I support both throughput and IOPS GP3. GP2, IO1, IO2 are only for IOPS, SC1, ST1 are only for throughput, and magnetic on the other hand has neither throughput nor IOPS. Depending on your use case, you will be selecting a volume of your choice. So if you're looking for many transactions, either go for IO2 or best go for GP3. If you're looking for throughput or streaming data, go for SC1 or ST1 or go with your GP3. GP3 is the general answer for anything at least after December 2020. And last, you can go for magnetic in absolutely zero cases. There is no case that anyone can think of where you will actually go for magnetic type of storage. That in short is your volumes. Now, by the way, once I go to instances and I go and click on a launch instance over here, this part, and once I go down and once I expand my storage and I see these options, GP2, GP3, provisioned, this provisioned, or if you click on advanced, it will also tell you what type of volume are you looking for. So if I go for GP2, I understand this IOPS. If I go for IO1, I understand I can give my own IOPS as per the size. IO2 ratio, okay, pay attention very quickly. GP2 ratio is defined, 100 is minimum. IO1 ratio is 1 is to 50. So if it is 8, it becomes 400. IO2 ratio is 1 is to 500. So if it is 8, it becomes 4000. Similarly, this cold STD, I have, if I give the size over here, let's say I don't have IOPS, rather I have the throughput. For each 1 terabyte, I would give you 12 Mbps. So 125, I would be giving you 2. Similarly, if I go for this one, I would be giving you 5 Mbps up till maximum of 31 Mbps. Finally, if I go for magnetic, I have neither IOPS nor I have throughput. And in the end, if I go for GP3, I have both IOPS and throughput. This part, I want to believe you understand automatically now because we are done with our volumes. Tomorrow, we would be talking about our snapshots or how to take a backup of these specific volumes. And if I see, backup is pretty easy. Say, create a volume. Let's say I created this volume, and then just select, click on actions, create snapshot, give a name of the snapshot, and that's it. That's the backup for you, which is available inside snapshot. Done. From this backup, you can create a new volume. From a volume, you can create a backup. This part is easy. The interesting part that you actually want to see is, how do I create an automated backup? Assuming I want to create a backup every 6 hours or every 12 hours or every 8 hours for the next 1 year, and I want to take a special backup to monthly and a special backup yearly, and the backup I want to go and copy inside a new region. And I also want to, inside that new region, I want to keep it for a duration of 5 years. These complex scenarios, if you have to work on, how do you work on that? The answer is lifecycle manager. But this we are going to talk about tomorrow. Finally, if you don't have any reason to work on volumes, please go and delete it, because AWS would be charging you for you just creating a volume and a snapshot as well. So that's it. If you have any questions for volumes, you can ask me now.